Hello. Some of you might be in different places here in 3.3. Section 3.3 in a way is repetition of what you've learned in the past two chapters about trigonometric functions, except that we concentrate on what happens when you are on the unit circle. So we are going to look at circular functions, which are really trigonometric functions. We're going to find the value of those functions just like we've done before. We're going to determine the number with a given circular function value and then look at some applications. So we call the trig functions circular functions when we are in the context of the unit circle. And the unit circle, by the way, is a radius of 1. So we know this radius here has a distance of 1. This radius here has a distance of 1. And the interesting thing is that if you look at the formula for the arc length back from section 3.2, if your radius is 1, then when you substitute that 1 in place, it should be the other way around. R times 1, it will give you actually, and hold on, that's the other way around. My radius is 1 times the angle, so that gives you this result that theta and the angle are S. So what you're going to see all throughout this section is that instead of using the angle theta like we've been doing so far, either in degrees or in radians, now they use S. It's really not a big deal. As long as that angle, you know, whatever that variable is accompanied by one of the trig functions, you know that represents an angle. In this case, it's going to be in radians. Now, the interesting thing here is that this point of intersection we call X and Y. And in the past, when we look at cosine, we knew that that was X over the radius. But now, that radius is 1, so you have X over 1. So what is happening here when we are in the context of the unit circles, we can say that cosine of that angle theta, and here is that angle theta right there, that angle theta right there will be just X. And X is actually the coordinate, the X coordinate. It will be the X coordinate of the point of intersection of the unit circle and the terminal side. So remember, this is your initial side, this is your terminal side, here's your angle, and this point of intersection, X and Y, this is saying that cosine of theta will be equal to just X, as long as we are in the context of the unit circle. So that's also true when we look at sine. We learn that sine of theta is equal to Y over R. But if R equals 1, this is saying that sine of theta is only equal to the Y coordinate of the point of intersection of the unit circle and the terminal side. So sine of theta will be equal to Y. But only if we are looking at circular functions, only if the radius is 1. So in a way, it looks like we are redefining the trig functions, but it's just in the case that R equals 1. Cosine of theta equals X. Its reciprocal secant will be 1 over X. Sine of theta equals Y. Cosecant of theta equals 1 over Y. And tangent and cotangent remain the same because they're not really, they don't really involve R, the radius. Something else that is kind of interesting now, when we look at those rational functions that we know sine of theta over cosine of theta equals tangent, if we had that tangent of theta equals 1/2, now we can say that sine of theta equals 1 and cosine of theta equals 2. However, that's going to give you an error. This is not possible. So this would only be true if the radius is 1. So be very careful not to make this assumption right away, because if the radius is not 1, that's not possible. So that x and that y will actually be restricted. This is something else that we will use often. Remember what I mentioned about the angle. If the radius is 1, when you substitute the radius into this function here, then theta equals s. It's really just symbolic. S represents an angle in radians in this case. So s equals theta, and it's an angle in radians. So the definitions haven't changed. The only thing is that I'm trying to make you aware that s and theta are kind of interchangeable here. Something else that you're going to have to watch out for is the range of trig functions. We studied this back in chapter 1, and this will always continue to be true. So if you're looking at, say, sine of 45 degrees is equal to the square root of 2 over 2. This is what we're calling the range value. The angle itself is actually your domain. So remember that the range value, the values that you can have here for sine are between -1 and 1, and for cosine are between -1 and 1. There are no restrictions for tangent and cotangent. You can have any number right here, big, small, -0, as long as it's a real number. And secant and cosecant are the opposite of sine. So they will be less than -1 or greater than 1 or equal, and the same for cosecant. Now remember what I said. This is what we call the range value. This right here, the angle, it's your domain. So what we have right here are the restrictions for the range. For the domain, there are no restrictions for the sine and the cosine. Remember, the domain refers to the angle. So this is saying that for the sine and the cosine, there are no restrictions for the angle. The angle can be big, small, and in this case, that s that we use for the angle represents a real number. So that's your theta. Now, tangent and secant are a little bit different. Remember, by definition, tangent is a y over x, and secant is actually r over x. Whether we have a unit circle or not, this is saying that x cannot be equal to 0. Now, if we look at tangent at sine of theta over cosine of theta, and secant is 1 over cosine, this is saying that cosine of s or theta, whatever you want to use, cannot be equal to 0. So your angle, that angle theta or s, whatever you want to look at, cannot be equal to positive or negative pi over 2. It cannot be positive and negative 3/2 pi, and so on. So that's what this, as complicated as this looks, that's what this is saying right here. That for secant and for tangent, that angle cannot be a positive and negative pi over 2, positive and negative 3/2 pi. If you need to think in degrees, that's okay. But remember what I've said a couple of times is you have to get used to radians. So this, yes, this is 90 degrees and 270 degrees, positive and negative. So that's what makes cosine 0, and it will make tangent and secant undefined. However, when we get to cotangent and secant, is the reverse. That is x over y and r over y. Or if you're looking at the identities, that will be cosine of theta over sine of theta. So this time we're saying that for cotangent and cosecant, y cannot be equal to 0. that's saying sine of theta cannot be equal to 0. And so the angle cannot be equal to 0, or positive and negative pi, or positive and negative 2 pi, and so on. And that is for cotangent and tangent. Let me highlight that for you. Okay. Now, back to the unit circle. Remember, we are assuming that r equals 1, so the radius is 1, and they ask you to find sine and cosine. If you know the radius is 1, then you are looking, when you're looking at sine of 90 degrees and cosine of 90 degrees, it will be equal to the y and to the x of the point of intersection of the unit circle and your angle. So 90 degrees, when you measure your angle of 90 degrees, your point of intersection would be right there. And by the way, that point is 0 and 1. So this would be as simple as saying that sine of theta is equal to the y, which is 1, and cosine of 90 degrees equals the x, which is 0. Of course, now when we get into radians, things are a little bit more complicated because we are having trouble getting used to radians, but it's a negative pi over 2. So this time that would be over, let me go back there. It would be right here. And the point of intersection right here, I have to orient this real quick. I apologize. Okay, sorry about that. So let me try again. And we have this point right here, still acting funny. This point right there will be 0 and negative 1. So this would be as simple as saying that sine of negative pi over 2 is equal to the y value of that point of intersection, so it would be negative 1, and cosine of negative pi over 2 will be equal to the x in that point of intersection, and it would be 0. Let's do another one, and this one is negative 3.1416, which is not exactly pi or negative pi, but it's pretty close. So when you draw your angle, it will be about right there. So we're looking at this point of intersection, which is negative 1, 0. So that's the angle negative 3.1416, because it's approximately negative pi. So that's negative 1, 0. So now we have sine of negative 3.1416, and that is equal to just the y value, which is 0. Cosine is equal to negative 3.1416, and that will be equal to the x, which is negative 1. Now, in your book, they have some exercises where they actually do this with the unit circle, but I think it's kind of a waste of time to do that when you can do it on the calculator. So that would be as simple as taking in your calculator sine of 0.8. Just make sure that you check your mode. Your mode must be in radians. In all of chapter 3, your mode must be in radians. So now we just take sine. We take sine of 0.8. And let's say we take 4 decimal places. So I have 0.717356. So that will be 0.7174. But make sure you are in radian mode. Then tangent of 0.2, and that will be equal to 0.2027. The next one is a 1, so I would stop right there. Okay, now back to this type of exercises. We've seen those also in section 3.1, and these are basically exact radians, and therefore you want exact values. It is a circular function, but in this case we work them the same way that we worked them before. So the first thing is recognize the reference angle, and that would be, since you have a 6 in the denominator, is pi over 6, and that will be 30 degrees. So you know you're going to have to find cosecant of 30 degrees. Now we need to figure out where that angle is. So I take 13/6 pi, then divide that, write that as a mixed number, and that gives me 2 1/6 pi. So to get a coterminal angle, I need to subtract 2 pi, and that gives you 1/6 pi, or just pi over 6. So remember, this is your coterminal angle. So what this is saying is that cosecant of 13/6 pi is identical to cosecant of pi over 6. Identical. But it happens to be also the reference angle. So if you need to make a connection to degrees now, you're looking for cosecant of 30 degrees. And this is where you look at your triangle, and you have 30 degrees here, you have 60 degrees for this one, and I don't remember the side, so I usually try to go with memorizing the sine. So I use 1 over sine of 30 degrees, and that's going to be 1 over cosine of 60, so that will be 1/2, and this would be a 2. Okay, so that's your final answer. So these problems are no different from what we did in section 3.1. Here's another one. The reference angle would be pi over 3, but I'm going to take that angle and I'm going to write it as a mixed number, so that will be 3 2/3 pi. I'm going to subtract 2 pi. I'm going to change it into a mixed number, into a fraction, so it's 11/3 pi, and this will be minus 6/3 pi, and subtract, and that's going to give you 5/3 pi, which, by the way, it's 1 2/3 pi. And that's when it helps to look at your angles here. So you have pi over 2, you have pi, and you have 3/2 pi, and then you have 0 and 2 pi here. We need to figure out what are these numbers with a common denominator. So I'm going to take that and write it with a common denominator. So you multiply by 2, and that will be 10/6 pi. This will multiply by 3, and that will be 9/6 pi. So this one is bigger, so it will be an angle in quadrant 4. So we are right here, we are in quadrant 4. So that's telling me that I need to check, I need to get the sine from this angle from quadrant 4, and cosecant is actually y, or r over y. So the y is a negative, so it's going to be a negative. And then I just look at cosecant of 60 degrees, since this right here is the same as 60 degrees. And again, you look at your triangle, and that's going to be sine of 60, and that will be square root of 3 over 2. So if you're looking at your triangle, most likely you'll come up with 2 over square root of 3, but you need to rationalize, so it'll be negative 2 square root of 3 over 3. Okay, one more like this, and you have sine of negative 19/4 pi. And right away you can tell that the reference angle is pi over 4, which by the way is 45 degrees. But I need to look at negative 19/4 pi and write it as a mixed number. So that's going to be negative 16, 4 goes into 16 4 times, and then I have 3/4 pi. So when they're negatives, you need to add revolutions. But 2 pi won't be enough. 4 pi won't be enough because it will still be negative. So you actually need to add 3 times 2 pi. And we change that back into negative 19/4 pi. This will be a 6 pi. But if I get a common denominator of 4, it will be 24 pi. And that will give me 5/4 pi. That's 1 1/4 pi. Okay, so I need to look at this angle and how it relates to the other angles that I know that are on the axis, the quadrantal angles. So 0, pi over 2, pi, and then I have 3/2 pi, and that's 1 1/2 pi. But now I need to write them with a common denominator. So the 5/4, it's okay the way it is right there. But this was 1 1/2. This one needs to be written with a common denominator of 2. So that would be 6/4 pi. And so when you look at those two, this is larger, so the 5/4 has to be in quadrant 3. So what that tells me is that sine of a negative 19/4 pi is in quadrant 3, and it will be negative since it involves y. And now I just need to find sine of 45 degrees. And with your triangle, you get a 1 over square root of 2, but you rationalize and it will be negative square root of 2 over 2. Now, these exercises are very important. They're going to be calculator exercises when you have a decimal like this. And I will give you some more examples that are not decimals yet. But remember, the unknown here is that S. That S is no different from the angle theta. And in particular, they're saying that S would be in that interval. So anytime that you're looking for the angle, that's when you want to take the inverse tangent of 0.124894185. So that's why it's a calculator exercise, because that's a decimal right there. So make sure you are in radian mode for this too. Then you go, it would be as simple as saying second tangent and entering the 0.124894185. Close your parentheses, and it will give you an answer in radians. It's 0.1242508061. And it didn't tell me how to round it. It didn't even tell me what that was in decimals, but that will be 0. And if you divide pi by 2, you get approximately 1.57. So see, that is in that interval right there. Now, this next example is cosecant. We don't have a key for cosecant. So let me come back here and give you another example before we look at that right there, that example. Let me just go down and make some room right there. And let me see if I can grab this to move it. I need more room. Okay, so let's say this is another example, and you're asked to find cosine of S or theta equals negative 0.235. Okay, so it would be as simple as writing that S as inverse cosine of negative 0.2375. So I'm going to do it on the calculator. And I have second cosine of negative 0.2375. And I get that S equals 1.8105877. There's a problem here because S is supposed to be in the interval from 0 to 1.57. This angle that I just got, remember here is pi over 2, which is 1.57. Here is S, which is that pi is 3.14. And this one would be 3/2 pi, and that is 4.71. So it's giving me an angle that is actually in quadrant 2. And that's the only possibility. So if they give you that interval, the only other possibility that gives you a cosine that is negative would be here, but it's still not in quadrant 1. So there is no solution in the interval from 0 to pi over 2. Now, if they wouldn't have restricted it to this interval, we could have said there was a solution. Okay, the last example. Cosecant of S equals 2.0 or 2.104796423. Now, here is the catch with those. We have to be really careful, and we have to take the reciprocal of cosecant, so you have sine of S, and the reciprocal of that number, 1 over 2.10479642 and 3. You did that when we had degrees. You have to do it with radians because there is no key for cosecant. So then you will have inverse sine, actually S equals, that S right there, inverse sine of 1 over 2.10479642, and now we can do it directly on the calculator. So I go second and sine of 1 divided by 2.10479642, and that will give me S in radians, and it's 0.49508, so that will be 5.1. And that's correct because it is in the interval from 0 to pi over 2. Okay. Now, before I stop here, I want to remind you that you've seen this kind of problems all along. In chapter 1, you had equations that were like this. Maybe sine of theta equals negative square root of 3 over 2. And you were finding that angle theta. So the negative sign, since it's a sine of theta equals a negative number, told me that I had an answer in quadrants 3 and 4. The value, that's very important. The value right here should have given you a hint, and that is because your reference angle for sine to be equal to the square root of 3 over 2, the reference angle would be 60 degrees. Whether you do it with the triangle or memorizing. Then in quadrant 3, you subtracted from 100, actually you added to 180, you added the reference angle, and that gave you 240. That's one answer. And then in quadrant 4, what you did is you took 360 minus the reference angle, and it gave you 300 degrees. I mean, it looks very different from what we just did because we did it in the calculator. These are exact values. But the difference is that that angle is in degrees, and this is an exact value. if I gave you something similar, and this is chapter 3, if I give you cosine of theta, or S, equals a negative 1/2, and then I said theta is in the interval from 0 to 2 pi radians, okay? Then you're still doing something very similar. For example, you look at the sign and you realize that because of the sign, your theta, it's going to be in quadrants 2 and 3. I look at the value of 1/2, and that reminds me of radians, and it reminds me of exact values. So maybe the first thing I do is I think in degrees. And I think, oh, that's going to be 60 degrees. But since you're asked to find it in radians, then I have to think in terms of pi over 3. So think about what happens in degrees. In quadrant 2, you would take 180 minus the reference angle. However, here, it's pi minus the reference angle. Now, if you're in quadrant 3, you will take 180 plus 60, but since it's in radians, it's pi plus pi over 3. So your answers will be, you get a common denominator for that, and that will be 3/3 minus 2. So you have 2/3 pi, and then pi plus pi over 3, that will be 3/3 plus 1, and that will be 4/3 pi. So your answers would be 2/3 pi and 4/3 pi. So what's changing is not the values of the function, but what the angle is. It could be in radians or it could be in degrees.